Today's video will demonstrate how the unsorted set stores elements. Hello, I'm James Helfrich. The standard template library's unsorted set stores elements in a hash table. Well, what is a hash table and how does it work? Well, this video will explain all of that. A hash table is a data structure where elements are placed in buckets determined by the result of a hash function. In this example, our hash function takes the number and then sums the digits. For an example, 73 is 7 plus 3, which is 10. 93 is 9 plus 3, which is 12. 86 is 8 plus 6, which is 14. Now, from this number, we mod it by the number of buckets to determine which bucket it goes in. So 93, which is 12, is the hash function. We'll put it in bucket 2 because 12 mod 10 is 2. And 989, which is 17, 17 mod 10 is 7, so it goes in bucket 7. To see how this works, take a look at this example. Here we have a hash function which sums the values of each letter in a string. I will first insert int into my hash table. So what bucket is this going to go in? Well, the ASCII value of I is 105, and N is 110, and T is 116. 105 plus 110 plus 116 is 331. Now, notice how my hash function has 5 buckets. So 331 mod 5 is 1, so it goes into bucket 1. Bool is 100 plus 111 plus 111 plus 108. Add that all up and you have 430. 430 mod 5 is 0, so it goes in bucket 0. Char, if we sum the values of char, we get 414. Mod 5 is 4, it goes in bucket 4. Now I'm going to write a loop to display the contents of my hash function. And in bucket 0, I'm going to get bool. In bucket 1, I'll get int. Bucket 2 and 3 are empty, and in bucket 4, I will get char. Here's another example with a different hash function. This can take an integer as a parameter, and it's just going to return the value cast to an unsigned int, which is a size t. This hash function has 5 elements. When I insert 26, 26 mod 5 is 1, so it goes in bucket 1. 42 mod 5 is 2, it goes in bucket 2. 15 mod 5 is 0, goes in bucket 0. 44 mod 5 is 4, it goes in bucket 4. And 92 mod 5 is 2, which goes in bucket 2. So when I display the contents of the hash function, we'll see that bucket 0 has 15, bucket 1 has 26. Bucket 2 has 2 values, 42 and 92. Now, since 42 is inserted first, it goes first in the list associated with that bucket. This example is far more complicated. Here I'm going to hash a bunch of temperatures, and the temperatures come in as floats. And so my hash function is going to take the temperature, subtract it by some minimal amount, negative 40 degrees in this case, and divide it by my temperature range, which is 110 minus negative 40. I'm going to multiply the whole thing by 8 because I have 8 buckets in my hash table, and that'll give me my hash function once I cast it to an int. So we're going to start with 16. 16 minus negative 40 is 56, divided by 110 minus negative 40, which is 150, times 8 equals 2.986. Cast it to an int, it's 2, and that gives me bucket 2. The next one is 72.4. That's 112.4 divided by 150 times 8, which is 5.995. Once again, cast it to an int. I lob off the decimal point. That's 5. It goes in bucket 5. Negative 21, that gives 18.5 divided by 150 times 8, which is 0.986, which goes bucket 0. 101 gets bucket 7, and 98.6 also gets bucket 7. So when I display the contents of this hash function, we're going to see that negative 21.5 goes in bucket 0. We're going to see that 16.0 goes in bucket 2, 72.4 goes in bucket 5, and we have 2 elements in bucket 7. The first one inserted was 101.1, so it goes first, and then 98.6 goes last. This is example 14.1. 14.2, and 14.3 in the hash chapter of the C++ data structures textbook.